Welcome to GeoVenture. Enjoy the journey. Please like and subscribe. A cosmic question. Why do we have seasons? Have you ever stopped and wondered why our world changes so much throughout the year? One month you might be splashing in a pool to cool off. A few months later you could be bundling up in a heavy coat, watching your breath turn to steam. Leaves paint the landscape in red and gold before they fall, then branches lie bare. After a long sleep, tiny green buds appear, promising warmth and flowers. These amazing, predictable changes are the seasons. They happen like clockwork, year after year, shaping our lives, our holidays, even what we eat. But what is the grand mechanism behind this transformation? The answer is not a complicated, mysterious force. It is a beautiful, surprisingly simple story about our home planet, Earth. Consider this: the big picture, a tilted planet on a grand tour. Picture Earth not just as a map, but as a giant sphere spinning in the vastness of space. This spinning motion is called rotation. Earth rotates on its axis, an imaginary line running straight through its center from North Pole to South Pole, once every 24 hours. This steady spin gives us day and night. As your part of Earth turns to face the sun appears to rise, daytime. Turn away, the sun appears to set, nighttime. It is a continuous, waltzing motion we all share, but that is not the only motion Earth is making. While it spins like a top, it is also on a much longer journey. Earth moves in a giant, nearly circular path around the sun. This path is called an orbit, and it takes about 365.25 days to complete. 1 year. Every birthday marks another full lap around our star. This constant movement, called revolution, is the second key piece, like a spinning basketball carried around a track. But there is a crucial detail to add, the most important part of our story. The secret ingredient: Earth's 23.5-degree lean. Here it is, the moment we have been waiting for. The secret: Earth is tilted. It does not spin straight up and down relative to its orbit. Its axis, the line from the North Pole to the South Pole, is tilted about 23.5 degrees. This tilt is called axial tilt, or obliquity. It is why we have seasons. This tilt stays remarkably stable as Earth orbits. That lean keeps pointing the same way in space, toward Polaris, the North Star. It does not wobble back and forth during the year. So for part of the year, the northern hemisphere tilts toward the sun. 6 months later, on the other side of the orbit, it tilts away, still pointing the same direction in space. In June, the northern hemisphere leans toward the sun. Sunlight is more direct. The sun appears higher. Rays hit the ground at a steeper angle. Days are longer. Extra energy warms land, air, and water. This is summer, like a flashlight straight on, more concentrated light. Fast forward to December. Earth is opposite. The northern hemisphere leans away. Rays arrive at a shallow angle. Days are short. Things cool down. This is winter. Less concentrated light means less heat. Sunlight's slant. How angle affects everything. Let us dig deeper into sunlight's angle. It is a big deal. Direct light is more concentrated and powerful. Imagine warming your hands over a fire. Directly above warms quickly. To the side feels gentler. When the sun is overhead, energy is concentrated. That is summer when your hemisphere tilts toward the sun. The sun climbs higher at noon. Rays strike nearly vertically. Each square meter gets more energy. In winter, your hemisphere tilts away. The sun's path stays lower. Rays arrive at a shallow angle and spread out. Feels weaker. Angle also affects day length. Tilted toward the sun means more hours of sunlight. Long, leisurely summer days. More daylight equals more warming. Short nights mean less cooling. Tilted away in winter is the opposite. Shorter days, less warming time, and long nights that let heat radiate into space. That is why winter is colder. It is all about angle and duration of sunlight. As Earth makes its annual trip around the sun, there are 4 special moments we mark on calendars. These are the solstices and the equinoxes, the extremes and balance points of Earth's tilt relative to the sun. Think of them as the official starts of each season. They are precise astronomical events based on Earth's position, peaks and valleys of the sun's path across our sky, all from that 23.5-degree tilt. Let us start with the solstices. Solstice comes from Latin, sun to stand still. Those days, the sun's apparent path reaches highest or lowest and seems to pause before reversing. Summer solstice, around June 21st in the northern hemisphere. North Pole tilted maximally toward the sun. Longest daylight. Official start of summer. Sun, highest and most direct. Around December 21st, winter solstice in the northern hemisphere. Shortest daylight, longest night. Official start of winter. Sun's path lowest and rays weakest. In the southern hemisphere, these are flipped. Summer in December, winter in June. Between solstices lie the equinoxes, equal night. On these days, neither hemisphere leans toward the sun. Day and night are roughly equal worldwide. Vernal equinox, around March 20th, marks spring in the north. Autumnal equinox, around September 27th, marks autumn. The sun rises due east and sets due west for almost everyone. They are the perfect balance points in the seasonal cycle. 4 milestones, 1 graceful orbit. One fascinating consequence of Earth's tilt is the opposition of seasons between hemispheres. It perfectly illustrates how the tilt works. While someone in Chicago is pulling on a warm coat in January, someone in Sydney is heading to the beach to cool off. Same sun. Opposite effects, because they live on different halves of our tilted planet. This global seesaw is strong evidence. Axial tilt, not distance, causes the seasons. In June, July, and August, the northern hemisphere tilts toward the sun. Long days, high sun, warm temperatures across Canada, Japan, and Italy. Meanwhile, the southern hemisphere tilts away. Short days, low sun, cool to cold in South Africa, Chile, and New Zealand. Christmas in Australia? A summer holiday, often with a barbecue. As Earth continues, December through February brings southern summer and northern winter. People in the northern United States ski, while people in Brazil enjoy peak beach weather. Near the equator, the sun is almost overhead most of the year. Angle and day length change little, so seasons are often wet and dry rather than hot and cold. Your location on our tilted sphere determines your experience of the year. The changing seasons are more than a meteorologist's topic. They are woven into our lives, cultures, and the natural world. For thousands of years, humans adapted to this predictable cycle. Agriculture depends on seasons. Plant in spring as ground thaws and days grow longer. Tend through warm summer, harvest before winter. The seasonal clock dictates our food supply. Animals march to this rhythm. Migrations, hibernation, transformations. Many birds migrate thousands of miles. Others hibernate, sleeping through the coldest months. Some change coats, camouflage with the season. Our behavior shifts too. Clothes, hobbies, holidays. We trade shorts and t-shirts for sweaters and parkas. Summer brings swimming, hiking, festivals. Winter brings skiing, skating, cozy evenings by the fire. Plants tell the story. Spring sprouts and blooms, summer photosynthesis, autumn's colors, and leaves falling to conserve water. You do not need a lab to see how tilt creates seasons. You can demonstrate this at home. Use a lamp without a shade for the sun and any ball for earth. Draw where you live. Tilt the ball. Keep the lean consistent, about 23.5 degree. Orbit the lamp, keeping tilt pointed the same way. Your spot gets direct, longer light on one side, summer. Halfway around, light is shallow and dimmer, winter, with shorter days and longer nights. Sideways tilt shows equinox, light evenly shared. How cool is that? So, there you have it. The sweeping changes of the seasons, spring's green shoots and autumn's golden leaves, are orchestrated by a simple, elegant fact. Earth is tilted. That 23.5-degree lean plus our yearly journey creates a beautiful, predictable rhythm. It is not about distance. It's about which part of Earth leans in to catch the most direct rays. This tilt fosters diverse climates, thriving life, migrations, harvests, art, stories, and our everyday routines. Next time you feel spring's first breeze or see winter's first snowflake, picture our tilted Earth in its grand dance and just look up and wonder.